sorry about that, a bit late for today's lesson, but good morning and good afternoon. Today what we're going to be doing is we're going to be looking at how to apply the skills learned in finding upper and lower bounds, and actually doing a couple of practical questions that you might see in exams and tests. So let's have a little look here. We've got a rectangle. It's got a length of 14 centimetres and a width of 5 centimetres. Both the nearest centimetre. That's a bit key there, so let's underline it. Both the nearest centimetre. Find the maximum possible area and the minimum possible area. So to do that, we've now got to look at the upper and lower bounds of each dimension. So the 5, that's obviously the height of the rectangle, is measured to the nearest centimetre. So I've done an upper and lower bound here for our height of 5. So remember, nearest centimetre, we put a 1 in there. We go half back, half of 1 gives us 4.5. And that's going to be our lower bound. And our upper bound is going to be 5.5. So 5.5 there for our upper bound. So we've got our lower and upper bounds of our height dimension. Now our base dimension, which is 14, exactly the same thing here to the nearest centimetre. So applying the same rule, 13.5 will be our lower bound and 14.5 will be our upper bound. Everything's measured in centimetres. Now, part A of the question is asking us to calculate the maximum possible area. So the maximum possible area means we want the biggest possible rectangle. So the biggest possible rectangle is going to happen when we've got the biggest base and the biggest height. So what we're going to do is we're going to multiply our biggest height, because remember, area of rectangle is base times height. A little bit of a recap there. So we're going to find out the biggest base there, which is the upper bound. There's going to be 14.5. Multiply that by our biggest height, which is 5.5. And I'm going to cheat. I'm going to use a calculator here. So let's go here. So 14.5 times by 5.5. That gives us 79.75, and our units are centimetres squared, because remember it's area. So that would be the biggest, the maximum possible area. In the same way, they're asking us to find the minimum possible area. So in other words, that's going to be the smallest rectangle that we could have. So we're going to do exactly the same thing, but using our lower bounds. So our smallest base is going to be 13.5, multiplied by our smallest height, which is 4.5, and out with the calculator again, so 13.5 times 4.5, that gives me 60.75 centimetres squared. So those are going to be the upper and lower bounds of the area. So in other words, the maximum possible, 79.75, and the minimum, 60.75. That's that sort of problem. Okay, let's have a look at another type here. Harry and Peter take part in a race. It took Harry 30 seconds to the nearest 10 seconds to finish the race, and it took Peter, who's obviously a lot slower than Harry then, 43 seconds to the nearest second there, to finish the race. So in other words, I've set out little diagrams, our upper and lower bound diagrams for us, work out the minimum possible difference between their finishing times. So let's focus first of all on working out the upper and lower bounds. Okay, so we've got 30 to the nearest 10, so half of 10 is 5, so we go 5 down from 30, gives us 25. 5 up from 30 then gives us 35. That's our upper and lower bounds there, so lower and upper there. Okay, now Peter, he's a slow coach, isn't he? So we've got 43, so 1 there, so he's going to be 42.5. And the upper bound is 43.5. Remember our check here, difference between these two is the 1, so we know we've got it right. So that's going to be our upper and our lower. Now, the minimum possible difference. Now, difference, remember, means take away, the difference between two numbers, taking them away from each other. Slowest sort of distance between them. Okay, so work out the minimum possible difference between their finishing times. Now it's not going to be Peter's lower bound, in other words his quickest time, take away Harry's quickest time. That won't work, because all you've got to do is get the gap. What we've got to do, we've got to think outside the box here. To get the smallest possible difference between their two times, we actually want Peter, who's the slowest, we want his quickest time, which is his lower bound, and we want to take away Harry's longest time, which is the upper bound, and that will give us the shortest gap between the two. So we get marks for working out these upper and lower bounds, but now having to think to work out, get those final marks and apply them. So, in other words, the minimum difference is going to be 42.5, which is, let's call it Peter fast. He's not really, but Peter fast. Take away Harry slow, and that will give you the smallest number. So Harry slowest, which his slowest time was 35. So the gap between the two of them there will be 7.5 seconds. If they were asking you for the maximum possible difference, all you would do is you'd work it the other way around. So in other words, you would take the 43.5, in other words Peter's slowest time, take away Harry's quickest time, and you get a much bigger difference between the two. So that's an introduction on how to apply the skill that we've learned in questions using upper and lower bounds.